Good morning, students. We'll discuss the alternating current, some important problems we'll discuss. See. Okay. An alternating current is given by I is equal to I1 cos omega t, I2 sin omega t. IRMS current, RMS current is given by how much? So here I1 cos omega t is there. Here I2 cos sin omega t is there. Phase difference between them will be equal to 90 degrees. So then I value will be equal to square root of I1 square plus I2 square plus 2I1 I2 cos 90 degrees. Phase difference between them is 90 degrees. So here I value will be equal to square root of I1 square plus I2 square. This is maximum current. Here I1 is there, na? This is maximum current. I2 is maximum current. So this will be maximum current. They are asking RMS value of the current is how much? So this will be I naught by root 2. This is maximum current. Okay. So then what will happen? Square root of I1 square plus I2 square divided by root 2. So if you write it, then IRMS is equal to square root of I1 square plus I2 square by 2. Okay. Option for this will be this one. Already we printed in the bold letters. Easily you can identify the answer. Okay. Next, see the next question. An alternating EMF is connected across a series combination of resistance and inductance L. The potential drop across R is for 200 volt and across L is 150 volt. What is the applied voltage? So circuit will be LR circuit. This is L, this is R. Both are connected to an AC source. Okay. And then in LR circuit, V is equal to square root of VL square plus VR square. So this value will be 150 whole square plus 200 whole square. Okay. So this will be 22500 and this will be 400. So this is square root of 62500. Then V is equal to 250 volt. So second option will be the answer for it. Okay. Let's see the third question, what they are asking. In LCR circuit, voltage across RLC at resonance are 40 volt, 60 volt. Here typing mistake is there. And 60 volt. Respectively, what is the applied voltage at resonance? So what are the values they gave? VR is equal to 40 volt. VL is equal to 60 volt. VC is equal to 60 volt. V is is equal to how much? At resonance, they are asking that. At resonance, V is equal to VR, simply. At resonance, V is equal to VR. So what is the answer for this? Means 40 volt. So this is the answer for it. Already answer is in the bold letters. You can identify. Next, what they are asking, see, in the given circuit, the reading of the voltmeter and ammeter are, this is inductor, this is capacitor. PD across the inductor and capacitor both are same, 400 volt, 400 volt, means circuit is in resonance. At resonance, PD voltmeter, this V1 reading means voltmeter reading across the resistor will be equal to applied voltage. So write down, given circuit is in resonance. At resonance, V is equal to V1. VR. This V value 220. VR, how much they are asking? VR is equal to 220 volt. What is the ammeter reading? Current. I is equal to VR by R. VR value 220. Resistance they give 100 ohms. See here in the diagram. This value is 100 ohms. So it becomes I is equal to 2.2 amperes. That is the current flowing through the circuit. So 220 volt, 2.2 ampere. This is the answer. Next, in LCR series circuit, with 100 ohm resistance is connected to an AC source of 200 volt and angular frequency 300 radian per second. When only the capacitor is removed, current lags behind the voltage by 60 degrees. When the inductance is removed, current leads the voltage by 60 degrees. The current and the power dissipated in the circuit will be how much? They are asking. Okay. Yes, LCR circuit taken. LCR. This is connected to an AC source of 200 volt. It's connected to an AC source of 200 volt. Then in this circuit, first they removed capacitor. When capacitor is removed, this circuit will become as LR circuit. Then phase difference between current and voltage will be 60 degrees. Okay. So in LR circuit, tan pi is equal to XL by R. So here 60 degrees they gave XL by R. Let it be equation. Later, inductance is removed. When only the inductance is removed, again current leads, initially lagging. Now it becomes L removed means circuit will become as CR circuit. So in CR circuit, tan pi is equal to xc by r. Tan 60 is equal to xc by r. Let it be second equation. Now these two are equal, not tan 60, tan 60. So these two are equal. So from 1 and 2, we can write XL by R is equal to XC by R. Therefore, XL is equal to XC. XL is equal to XC means circuit will be at resonance. Okay. Therefore, circuit is at resonance. At resonance. I is equal to VR by R. Here VR or V, applied voltage. Applied voltage is 200. Resistance they gave 100. So it becomes 2 ampere. Applied voltage will be 200 volt. Resistance will be 100 ohms. VR value is nothing but V only, na? Because at resonance, V is equal to VR. So here we can write V by R also. Same meaning will come. So that will be 2 amperes. And power is how much? Power P is equal to V into I. It's 200 into 2. So P is equal to 400 watt. So this is the answer for it. Okay. Next, see the sixth question. An AC source is connected across a resistance of 10 ohms. Power dissipated in the resistor is 100 watt. RMS value of current and voltage will be how much? Let's see, P is equal to V square by R. This P value 100, V square, R value 10. V square is equal to 1000. V is equal to root 1000 volt. One more thing they are asking, what is the current? P is equal to V into I. P value is how much? 100. V value how much? Root 1000 means 10 root 10 into I. 0, 0 will cancel. 10 by root 10 this is. So I is equal to root 10 amperes. Okay. So this will be the answer for it. RMS value only, it is connected. RMS values means direct again, no need to take. Next, seventh question. Step down transformer input voltage VP is equal to 22,000 volt. Vs is equal to 550 volt. Number of turns in the secondary by number of turns in the primary is how much? Ns by Np is equal to Vs by Vp. So Vs value 550. This is 22,000. 0 will cancel. This value will be 1 by 40. Ns by Np is equal to 1:40. This is the answer for it. See the next question. In a transformer, number of turns in the primary and secondary are NP is equal to 1000. NS is equal to 3000. Primary is connected to 80 volt AC. Potential difference across each turn in the secondary. Vs by Ns is equal to how much they are asking. See here, what is the formula? Ns by Np is equal to Vs by Vp. Vs by Ns is equal to Vp by Np. Vp value 80. NP value 1000. So how much we are getting this value? 0.08. This will cancel. So this value will be 0.08. So option for this is this one. Okay. See the ninth question. A small signal voltage V is equal to V naught sine omega t is applied across an ideal capacitor C. So in capacitor, when AC is connected to the capacitor, AC source is connected to the capacitor, what will happen? Current leads EMF by a phase difference of pi by 2. Okay, already you know this. So first option you check, current lags voltage. So this will be wrong option because current is leading. Over a full cycle of capacitance, cycle of the capacitor C does not consume any power from the voltage source. This will be the answer for it. Why this is the answer means, here P average is equal to ERMS IRMS cos pi. This phi value will be equal to pi by 2. So cos pi by 2 will be 0. So this value ERMS IRMS cos pi by 2. This is equal to 0. That's why it won't consume any power or any energy. Current is in phase with the voltage. You know, current leads EMF by pi by 2. Current leads voltage by 180 degrees, 90 degrees only. So these two options will also be wrong here. B will be the answer for it. See the next question, what they are asking. Current I in the inductance is varying with time according to the plot shown in the figure. Which one of the following is correct variation of voltage with time in the coil? So here between in an inductance, how current is varying with time, they are represented by a graph. How voltage is varying with time, we have to draw the graph. See here, up to t by 2, 0 to t by 2. Current is linearly increasing with time, means voltage will be a positive constant value. Here current t by 2 to t, what will happen? Current is linearly decreasing with time. So then it will be a voltage will be a negative constant. So this graph will be the answer. So what to write? In between 0 to t by 2. Current is linearly increasing with time. Therefore, voltage is a positive constant. Next, in between T by 2 to T, current is linearly decreasing with time. Therefore, voltage is a negative constant. Okay, so this will be the answer for it. So how the graph shape will be there means up to T by 2. It is like this. Here voltage, here time. Next, see the next question. Instantaneous values of alternating current and voltage in a circuit is given by I is equal to 1 by root 2 sine 100 pi t, E is equal to 1 by root 2 sine 100 pi t plus pi by 3 average power. P average is equal to M. What is the formula? E RMS. I RMS cos pi. E RMS is E naught by root 2. I RMS is I naught by root 2 into cos pi. Then see. Here 1 by root 2, 1 by root 2 means 1 by 2. E naught value here how much? This is E naught value. This value will be E naught. This value will be I naught. So root 2 will be 1 by 2. E naught value 1 by root 2. I naught value 1 by root 2 cos pi by 3. So finally, this value will be 1 by 8. Cos 60 is 1 by 2. Na? So finally, this is 2 again. 2 into 2 into 2. This value will be 1 by 8. Option for this will be this one. See the next question. What they are asking, say. Figure shows a circuit that contains 3 identical resistances with resistance 9 ohm, 2 identical inductors with inductance 2 millihenry each, and an ideal battery of EMF 18 volt. The current I in the battery just after the switch is closed. Now, this switch is closed. Just after that, what is the current? This current is starting from here now. It will comes to here. It starting inductor will have infinite resistance. So current won't go in this manner. It won't go. It will goes like this. And when it is coming like this now, it will also have, it will travel like this, but here again it is having infinite resistance, so it won't go through this. Is the point understanding what I am saying? May I draw once again graph that circuit. What is the circuit given here? Like this. Here battery is there. Here straight lines are on this pad. A little bit difficult to draw. Less friction is there. Here inductor is there. Here resistor. Here only resistor. Again here resistor and inductor. For this again one capacitor. Then what will happen just after the switching? Current will start from here. It will comes to here. It won't travel through this way. Why it is not traveling at starting? Inductor is having infinite resistance, so it won't travel. It will travel through this. It won't travel through this also. Why means this is some resistance value. They gave it is 9 ohms. This is at starting, it is having infinite resistance. These two are in series. Na? Infinite plus 9 is equal to again infinite. It is having infinite resistance. So current won't travel in this path, and this current, what is the current it is there, it will travel only through this resistor and reaches the negative terminal. So what resistance is included? Only this 9 ohms is included. What is the current in the circuit? I is equal to V by R or E by R. This value is 18. This value is 9. So current will be 2 amperes. So what is the concept you have to remember here? At starting, infinite, the inductance will offer infinite resistance. Okay. Next, see the next question. Inductor is there. Its inductance is given. Capacitor is there. Resistor are there. What is the power loss in the AC circuit? So they are asking average power is how much. Okay. So here little bit calculations will be there for this. So here find LCR circuit only. Here XL value will be equal to, we'll write one by one. XC is equal to 1 by C omega. C value 15 microfarad. Omega value sine omega t. So this is omega. This will be 340. If you calculate this value, it will be 58.8 ohms. XL value is equal to L omega. L value will be 20 millihenry. Omega value will be 340. If we calculate this one, this is 6.8 ohms. Then the impedance value will be Z is equal to square root of XL minus XC whole square plus R square. So Z is equal to, this is 6.8 minus 58.8 whole square plus R value will be 40 square. We will get this value as, this is 52 whole square plus 40 square. So finally this value will be Z is equal to square root of 4304. ohms. You just keep like this. Then power consumed, they are asking average. So P is equal to IRMS square into R. This is VRMS by R whole square Z here. Into R. Then you substitute that values. VRMS is equal to here. This is V naught na 10. VRMS is V naught is 10 means VRMS is equal to V naught by root 2. This will be 10 by root 2 volt. So here this value, if we substitute 10 by root 2, this value 4304 whole square into resistance value is 40. Okay. So here it will be 100 10 square, 40 is there. This 2 will comes to denominator. This will be 4304. My here numerator 4000 is there. Here denominator 4300 is there. Slightly 1 point something will come. Approximately it is 1 by 2. This value, if you calculate, 0.51 watt will come. So this is the answer for it. Okay. Next, see the next question. What they are asking. 14. A resistance R draws a power P when connected to an AC source. If an inductance is now placed with the resistance such that the impedance of the circuit becomes Z, the power drawn is how much? So here P is equal to I RMS square into R. So V RMS by R whole square into R. This is initial. When inductor is connected, P dash, this value VRMS by Z whole square into R. P by P dash you do. This VRMS will cancel, RR will cancel. This value will be Z square by R square will come. Then P dash is equal to R square by Z square into P. Or P dash is equal to R by Z whole square into. So R by Z whole square into P. So this is the answer for it. Okay. Next. 15th question. What they are asking, say, series RC circuit is connected to an AC circuit. This is R, this is C. These are connected to the AC circuit. Consider two different situations. One situation, capacitor is air filled. In another situation, capacitor is mica filled. Here air is there, here. In the second case, gap between them is filled with mica. Then in which case current will be relation between currents, and this is case A. This is case B. Where current will be more, where voltage will be more, that is the question they are asking us. Okay. Now here, what is the impedance of the circuit? Z is equal to R square plus XC square. XC value will be how much? 1 by C omega. Okay. And I value will be how much? This E by Z. Now, what will happen here if you consider this case for mica filled capacitor. Capacitor is filled with dielectric, its capacity will increases. Filled with mica, capacity will be more. This capacity more means XC value, what will happen? Decreases. XC decreases means Z, what will happen? Decreases. Because Z is equal to this one, R square plus root R square plus XC square. XC decreases means Z will decreases. Resistance decreases means current in the circuit, what will happen? Increases. Means this current is increasing means voltage across this resistor is increasing. Therefore, voltage across resistor will increase, then voltage across capacitor will decrease. Okay, so here potential difference is then what will happen? VC will decrease. So means here this value is less, here this value is more. Therefore, VA value is greater than VB. Okay, see the next question. Transformer is having efficiency 90%. Okay. Input power, input voltage is given. Secondary coil current, secondary current is given. So what are the given values you see? Eta is equal to 0.9. Vp is equal to 200 volt. P in is equal to 3000 watt. And current in the secondary coil is 6 ampere. Voltage across the secondary coil, how much? Current in the primary coil, how much? They are asking. Eta is equal to P in by P out. Na? Using this, we can find I in is how much? Na? Current in the primary circuit, we can calculate. Using this P, and so here P in is equal to Vp IP. Then IP value will be 15 amperes. And one more thing they are asking, voltage across the secondary, Vs is how much? IP, Vp, we know. Vp, IP, we calculated. Vs, Is, we can calculate. Na? So using Vs by Vp is equal to IP by IS. VS by VP value, they gave it as 200. IP value we calculated here as 15 ampere. IS value, they given it as 6. Okay. No, here Efficient, it is not perfect, na? It is not ideal. We'll do like this. Then. Ideal only we will get like this. From eta is equal to P out by P in 0.9 P out. And here only we will substitute. This is equal to VS IS by VP IP. VS we don't know. IS they given it as 6. VP IP. VP IP. 200 into. If we calculate this one finally, BS value will be 450 volt. So answer for this will be this one. Okay. Next, power dissipated in the circuit, how much they are asking. So how to do this one? See, in the AC circuit, VI values are given, and V here I is equal to should be there. Typing mistake. I is equal to. Then P is equal to ERMS, IRMS cos phi. ERMS will be E naught by root 2. I naught by root 2 cos phi. This is 1 by 2. E naught value 150. I naught value 150. Cos pi by 3. So this value 22500 and by divided by 4. So if we calculate this value, P is equal to 5625 watt. See the next question, 18. What they are asking, say, RMS value of current is given. Peak current is how much? Simple question. IRMS is equal to I naught by root. I naught is equal to root 2 into IRMS. Root 2 value 1.414, RMS value 25. If we calculate this one, 35.35 ampere will come. This is the answer for it. Next, see the next question. Coil is there. Inductance is 0.01 Henry. 1 ohm resistor is there. It is connected to 2, so LR circuit. Time lag between maximum voltage and current is how much? So in LR circuit, tan pi is equal to XL by R. L omega by R. L value 0.01. Omega 2 pi F by R value will be 1. So tan pi is equal to 3.14 if we calculate this one. And then pi is equal to tan inverse 3.14. This value will be 72 degrees. Convert this into radian. So pi is equal to 72 into pi by 180 radians. This is 4, this is 10. So 0.4 pi radians. So omega is equal to pi by t or theta by t. Pi by omega. 0.4 pi by 2 pi into 50. Pi will cancel. And if we calculate 0.2 by, so finally this value 1 by 250 seconds. That is the t value. Okay. Next, see the next question, what they are asking. 5 microfarad capacitor is there connected to 200 volt, 100 volt, 100 Hz AC source, capacitive reactance 1 by C omega. 1 by C in value 5 into 10 power minus 6. 2 pi into 100. So this value, if we calculate, finally this value 1000 by 3.14 will comes. So this value 318 volts. Okay, we'll stop this session now, enough, and we'll continue in the next session. Okay, thank you all.